All right, so we're looking at radicals today. And the main thing to do when you're looking at radicals is to carefully pay attention to the directions. So up at the top it says, simplify each expression, write all irrational answers in what we call simplest radical form. Simplest radical form. What do you think that means? Does anybody know what that means? Means no what? What happens if you type in the square root of 9 on your calculator? What do you get? You should get a 3, right? Square root of 9 is 3. What happens if you type in the square root of 10? Square root of 10 is going to give you a decimal, something like 3.0 blah, 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 something. Okay? So they want your answers in simplest radical form. That means either a radical with a number under it that doesn't have any perfect square factors, or if it's a perfect square, then just your number without a radical. Okay? So the easiest way to do it is to check on your calculator and see if it's a perfect square. So for box number 1, we're going to take the square root of 49. And so on these calculators, you're going to use the button that says second. Some calculators, it's shift. Some calculators, it's a little arrow that points up. And then you're going to go to this button that says x squared, and above it, really small in light blue, has a square root. So when you push that button, it should display a square root on your screen. And then you simply type 49, hit the equal sign, and it gives you 7. Most of you knew that, right? Okay. And most of you know your perfect squares probably up to at least 100, maybe even up to 144, right? Like the square root of 1 is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and then obviously 10 squared is 100. So those will be helpful, but when you get the square root of 361, you might not recognize that. So we don't know if it's a perfect square or not. You simply test it on the calculator by typing it in, square root of 361, hit the equal sign, 19. If it's a nice number like that doesn't have numbers after the decimal point, just write it down. But if you took the square root of 362, watch what happens. Big old decimal. So they don't want that. They don't want decimals. That's what simplest radical form means. No decimals. Shrink it just a tad. Number 14 says the square root of 1 over 16. Most of you recognize that 16 is a perfect square, right? But you can take this and separate it to the square root of 1 over the square root of 16. What's the square root of 1? 1. And the square root of 16? 4. Now, if you did this on your calculator, what's it going to give you? You type in the square root of 1 over 16. What's your calculator going to display? Let's try it. If you go to the square root of 1 divided by 16, it gives you a decimal. 0.25. Now, a lot of you could recognize that that's a fraction, right? Most of you would know, oh, okay, that's 1/4. So try and see if you can separate it first. All right? Jumping down to number 15. We have the square root of 80. Now, I know that the square root of 81 is 9, so I'm pretty sure that the square root of 80 is not going to be perfect, right? Giving you this decimal. Okay, so we can't use the square root of 80, but does the square root of 80 have any factors that are a perfect square? So you could take 80 and test it. So I'm going to take 80 and see if 16 is a factor, because I know 16 is a perfect square. So I'm going to take 80 divided by 16. That means that 16 times 5 is 80. So watch how I'm going to do this. I'm going to say that square root of 80 is equal to the square root of 16 times the square root of 5. And I know that the square root of 16 is 4, so this is 4 square roots of 5. And 5 does not have any perfect square factors, so this is what's called simplest radical form. Okay, so you want to take your calculator and check and see if any of these numbers are factors of the numbers that are under the radicals. And then you can simplify it. Okay? So let's try number 16. We already have a coefficient of 2 out front. And then under the radical, I have 360. Now it's kind of obvious what's going to be a perfect square factor of it. 36, right? You see the 36 in there? That one's obvious. So we're going to rewrite it as the square root of 36 times the square root of 10. Because if you multiply 36 and 10 on your calculator, you're going to get 360. So in the next step, I'm going to say 2 times, and then I know the square root of 36 is 6, square roots of 10. 2 times 6 is 12. Right? This is one method you can use to simplify radicals. Another method you can use is called getting the prime factorization. Okay? So you see how for number 15, I got 4 square roots of 5. The other way to do it is to take the number that's under the radical, which is 80, and then get all the prime numbers that go into it. I know 80 is even, so I factored out a 2, because 2 times 40 is 80. And then with the 40, I said 2 times 20. For the 20, I said 2 times 10. And for the 10, I said 2 times 5. Okay? All these numbers are what we call the prime factorization. And each pair, when you multiply them together and take the square root, one will come out. So 2 times 2 is 4, and the square root of 4 is 2. 2 times 2 is 4, and the square root of 4 is another 2. This 5 does not have a pair, so it stays under the radical by itself, and then you just simplify, 4 square roots of 5. So notice I got the same answer, it's just another way to do it. So you can either look for perfect square factors, or you can do the prime factorization. It's just 2 different ways of doing the same problem. Notice I got the same answer. All right? Jumping over to number 243. That one's a little bit trickier, right? We don't know what could be a perfect square factor of 243. So you could take your calculator and you can go, okay, 243 divided by 4. Doesn't go in there evenly. 243 divided by 9. Does go in there evenly. Okay, so we're going to rewrite this as the square root of 9 times the square root of 27. But you might recognize that 27 also has a factor of 9, right? So I'm going to write this as the square root of 9 times the square root of 9 times the square root of 3. And I know the square root of 9 is 3, the square root of this 9 is 3, and then bring down that square root of 3. 3 times 3 is 9, so this should be 9 rad 3. So whatever number's under the radical, you just keep this list right next to you and try and see what of those factors goes into that number. Okay? Let's look at number 18. rewrite the 4 that's out front. And then we're going to look at the 384. So 384, let's see if 4 goes into it. Yep, 96 times. So we're going to say the square root of 4 times the square root of 96. But 96 also has perfect square factors. So let's take 96. Well, let's rewrite the 4, rad 4. We can simplify the square root of 96 even more by dividing it by 4. And we get another factor of 24. And I know 4 is a factor of 24. So this is 4, square roots of 4, square root of 4, square root of 4, times the square root of 6. So is there an easier way? Sure, that means that 4 is not the smallest one. Ends up being that actually 64 is. So if you had tried a larger number than 4, you would find that 64 is a factor. But I'm going to simplify it as 4 times 2 times 2 times 2, rad 6. And then just take my calculator and go 4 times 2 times 2 times 2, and it gives you 32 rad 6. Kind of a longer way to do it, but it's not a decimal, right? You can't have decimals, so that's what it's got to be. All right, number 19, we have square root of 6 times the square root of 30. There are no perfect square factors of 6, and there are no perfect square factors of 30. So we can't simplify them in this form. So the first thing we're going to do is multiply those two together. What's 6 times 30? 180. Okay. So let's see if 180 has any perfect square factors. Obviously 4, but let's see if there's a larger one. Let's see if 36 goes in there. So 180 divided by 36 goes in there 5 times. So I'm going to rewrite this as the square root of 36 times the square root of 5. I know the square root of 36 is 6. So we have 6 rad 5. Yes?
Can you explain what you're doing?
Yeah. Which one are you stuck on?
I don't understand the method.
Okay, so do you know your perfect squares? No. Okay, I would start by writing those down.